Let's discuss 1.3, which is the translating word phrases into algebraic expressions. Remember that an algebraic expression is when you're using letters and numbers combined together to represent some value. Again, this is review. There isn't anything really new here that you haven't seen before. It's all been in pre-algebra. So let's talk about, before we do that, let's talk about a property that's called the commutative property, which basically states that when you're adding, for example, A and B, you can switch the order in which you're adding them and it does not change the value any. For example, if I had 2 plus 3, or if I wrote it as 3 plus 2, when I go to solve on both sides, I still get 5 equals 5. So this is a true statement, right? It didn't change just because I switched the order when they were adding. The commutative property also applies to multiplication. Remember, a letter next to a letter means multiply. So if I had A times B, or if I had B times A, they're still equal. Let me give you an example. 4 times 3, or if I switch the order and I write 3 times 4, when I solve on both sides, I end up still getting 12 equals 12. Again, this is a true statement. We call that the commutative property, which basically states that when you're adding or multiplying, the order doesn't matter as far as when you can switch the order. But when you're talking about subtraction or division, they are not commutative. You cannot switch the order. It does matter. The order does matter. Here's a perfect example. If I had 8 halves and I flipped it, made it 2 eighths, in other words, I switched the order, is that equivalent? Well, 8 divided by 2 is 4, and 2 eighths reduces down to 1/4. So as you can see, they are not equal. 4 does not equal 1/4. You can't switch the order. Same thing with 5 minus 3 does not equal 3 minus 5. Because 5 minus 3 is 2. Think of it as you have $5, you spent $3, you have $2 remaining, right? But here, what if you had $3, you spent $5? Well, then that means you're in the hole $2, right? So 3 minus 5 is a negative 2, and 5 minus 3 is 2. 2 does not equal negative 2. They're completely two values. You'd rather have $2 than owe $2, correct? They are not the same. So again, the commutative property does not apply to division or to subtraction. One of the things in the exercises that they'll ask you to do is they ask you to, on example 3.1, to apply the commutative property. So apply commutative property here. If they have x plus y, then you can write it as y plus x. Here they have 5x plus 4z. Now notice I'm going to put a line here right where that z is. Mathematicians do that because a lot of times z will look like 2 when you get to being a little sloppy in your writing. So if you see someone put a line through that, that means it's a z, not a 2. But we want to do the commutative property. So that means switch the order because they're adding. So I can say 4z plus 5x. Those would be equivalent. Here I have 6 times y. I can also write this as y times 6. And here I have 5 times g squared, or I can write it as g squared times 5. It doesn't change the value any because of that commutative property. I would, however, like to note that, for example, in this particular example here, you could have wrote this as 6y. Because remember, a number next to a letter, right, means multiplication. And so this is the appropriate way, really, to write 6 times y. You always put the coefficient in front and the variable at the end. You would not write y6. Okay, that would not be, that's not the acceptable. Same thing here, you would write this as 5g squared. You really wouldn't write g squared 5. That's just not what they normally do. And so this is more appropriate as far as when you're dealing with algebra. All right, so next, I'd like us to become familiar, if you look on page 9, and I hope we can see, everybody can see all this. Let me come over just a little bit. On page 9, look at the chart. It has keywords in the algebraic translation. So these are keywords that's important for you to become familiar with, to memorize, or to know. There are a lot of other words that can be used, but these are the ones that are probably most common. So if I look here, I have for addition the word exceed, gain, increased by, more than, plus, rise, sum, and total indicate that you're going to be adding. So when you see any of these words, you know you're going to have an addition problem. For example, I said, what is the total of 2 and 5? Well, that would mean 2 plus 5. The word sum means the answer to an addition problem. So if I said, what is the sum of 2 and 5? You would write 2 plus 5, and so forth. Then for subtraction, you have the words that indicate subtraction would be decreased by, difference, diminish, drop, less, less than, lose or loss, and minus. So all of these indicate that you're going to be subtracting. For example, the word difference means the answer to a subtraction problem. If there is a star here, and so I want to point something out here. If I said, for example, 9 or 9 less than a number, less a number, 9 less a number, 9 less a number. That would mean that I would be saying 9, less indicates subtraction, some number in. But if I say 9 less than a number, notice this was less, this is less than. When you see less than, it's like here we took the first number mentioned by minus the second number. But whenever you see a less than, it will always be the second number in minus the first number. So that's what they're saying here. It has a little star. If you come down here, there's some verbiage here. It says with less than, the result is the second number minus the first number. So you do need to know in that case, because order does matter in subtraction. And so there's a difference when you see, just say 9 less, then it would be like this. If it's 9 less than, then you're going to switch them. So that's something to keep in mind. Then you have multiplication vocabulary. For example, double, twice, triple, quadruple. The word of, that's really key. They use the word of a lot, translates into multiplication. Product is the answer to a multiplication problem, and times. Then when we look at the division, keywords that means to divide. Well, divide, divided by, half, 1/3, 1/4, etc. That's what that means, etc. 1/5, 1/6. That all means to multiply. Quotient means the answer to a division problem. And then you have the word ratio. Anytime you see the word ratio, that means put the first number that's mentioned in the numerator or on top, and the second number on bottom in the denominator. And we'll do some of those. And then equality, that indicates meaning equal. So equals, it says gives, okay, is the same as, I might say 2/4 is the same as 1/2. 2/4 is the same as 1/2, so it's indicating equals. Is, was, represents, results in, or yields. All of these are indicators that you have something that is equal, has an equality. So make sure you study and you know those very, very well. All right, so let's do some examples. Again, just so that you know, I'm going to go ahead and move this back up here. I think my lighting's just a little better when I do it that way. All right, so we talked about less than and the ratio. Okay, so we mentioned that, so now we're going to go ahead and do some examples. First one, it says 3 more than a number. So if you look on your chart, first of all, you got 3. More than implies that you're going to be adding. A number is the unknown. So you're going to put in a letter to represent the unknown. And I like to put in when I'm talking about a number. A lot of times when I'm doing story problems, the variable I choose, I like it to represent what they're talking about. If I was talking about a square, well, a square has a length and a width. So if my unknown was the length, then I would use the letter L as my variable. But in some basic translations like this, for the word number, I like to use the letter N. The book will use the letter X, and that's okay too. There's nothing wrong. You could have wrote 3 plus X. It doesn't really matter what variable you choose. It's just the unknown. Then we have another translation or another word here. Let's look at this one. It says a number increased by 5. So a number increased by indicates addition. By what? By 5. So your algebraic expression would be n plus 5. On our next example, it says a number diminished by 7. And if you know, a diminished means subtraction. That's a key word for subtraction, by 7. So a number diminished by 7. Here you have 7 decreased by a number. Decreased again is indicating subtraction. So 7 decreased by a number. Here we have 9 less than a number. Now remember, this is that less than. Remember, this was that 1. I'm going to put a little star there that they kind of told you that this is a little different. It wouldn't be 9 minus n. That you'd put whatever second. Okay, this is what's second, right? Put it first. Less than indicates subtraction. Whatever was the first number they mentioned will come last. So this should be n minus 9. So 9 less than a number, because it's saying 9 less, so 9 less than a number. On this one, so this one is 9 less a number, and so that would be 9 minus n. So that was that example that we had done before earlier. So remember, when you see less than, that one you've got to remember. Let's look at some more examples. Here we go. All right. Here we have the words twice a number. Twice, if you look on your chart, indicates multiplication. And it So not only are we going to be multiplying something here, I'll just put my dot here, times the number, but what number are we multiplying times the number? Well, twice means 2, okay? Twice as many times, so twice a number. Or you could have wrote 2n, all right? Here it says product of a number and 5. Well, product means the answer to a multiplication and the word of. So this is going to tell us that we're going to be multiplying something. We're going to be multiplying the number, right? And 5. So n times the number. Appropriate way to write that, though, is really 5n, okay? Next one is 6 divided by a number. So it's, some people might write this, 6 divided by a number. But if you remember when we talked about an algebra, we're not going to be using this symbol anymore. We'll be using the fraction bar. So 6 divided by a number. So it'd be 6 divided by a number. Okay? This is half of a number. Remember, of indicates multiplication, right? And it says half of a number. But I am not going to use the symbol for multiplication. You remember from our first section, right? Because it looks like an X. So I could use a raised dot. I could write it like this. I could write it like this, right? Or I could even write it like this. Would be n over 2. The best way to write it, though, is this right here. Half of a number. Half of an n. Then ratio. Remember, ratio, again, was one of those that was starred where it says the first number goes on top and the second number goes on bottom. So it says the ratio of a number to 10. Ratio indicates division, right? So we're going to use our fraction bar. And the first number mentioned will go on top, and it says number to 10. The second number will go on bottom. All right, now those are all algebraic expressions. These here, these examples, they're having you, write a math, what I call a sentence, complete sentence, or what I call a math sentence, okay? In other words, if you were doing English, you'd have to have your verb and you'd have to have a subject. Otherwise, it's not a sentence, right? And then, of course, you might have adjectives or those kind of things. But to be a complete sentence, you need a subject and a verb. Well, in math, you would have an algebraic expression set equal to some value. And in math, a math sentence is what we call an equation. So these are going to be equations. And so we're going to have those equality symbols. Also, to save space and time, instead of writing the word number out each time, I just put a little hashtag, which is like a number symbol. Okay? So for this example, that's what I'm using. So it says 3 more than a number is 18. So let's translate it. 3 more than indicates addition. 3 more than what? A number is, that's that equality symbol, 18. So 3 plus n equals 18. All right. Now this says twice a number. So twice a number, that means multiplication, right? Twice a number, decreased by indicates subtraction, decreased by the number, so the same number, equals 4. All right, this next one says 8 less than triple a number. All right, so I'm just going to write 8 here just for a minute. 8 less than triple a number. Well, triple a number would be 3n, so I'm going to write 3n here. All right, and gives is equal. Remember, this is that less than. So you wouldn't say 8 minus 3n. Remember, it's whatever's the second one listed, which is 3n minus 8. The word gives indicates equals 28. So the answer is 3n minus 8 equals 28. This is that special exception where the second one goes before the first one that's mentioned. And I think we have one more. 40 increased by 2/3 of a number is 50. So 40 increased by indicates addition. By 2/3, well, 2/3 is a fraction. 2/3 of indicates multiplication. So 2/3 of a number, so 2/3 in is 50. And you just now translated all these word problems. So again, your assignment is the essential problems that have the blue icon.